So when we look at paper 1, there's basically 2 topics that we've seen or that we've done so far. And topic number 1 is basically the algebra. So this algebra consists of how we solve quadratic equations. Okay. Then we can also look at the different methods. Remember, we looked at how we use the factors, but also how we use the quadratic formula in grade 11. Then on top of that, there is also what we call the quadratic inequalities. Okay, quadratic inequalities. So when I just go back to the quadratic equations, remember it is ax squared plus bx plus c, where you have to just look for the factors and then as well as use the quadratic formula, that is x is equal to negative b plus minus square root of b squared minus 4ac divided by the product of 2 and a. So that is the quadratic formula. Okay. With the quadratic inequalities, it's just going to be more or less the same thing, x squared plus bx plus c, but then we shall have either greater or equal to, or we shall have less or equal to. So this needs to be understood in the context of the functions, which functions will be just like a parabola, because we know that a quadratic function is more like a parabola. How do we answer such questions? Okay. We shall explore that and go into detail as we look at the sample questions. Then we should also look at equations. Okay, equations that involve the third form. In other words, you're given the square root of maybe x plus 2, maybe minus 3 should be equal to 9 or 9x plus a 3, something like this, for as long as there's a square root involved. These kinds of equations, we shall also look at it and how unique they are. Then besides those equations, we also discussed what we call the simultaneous equations. Okay, in grade 10, we're just looking at linear equations. But now in grade 11, we need to remember that one equation is going to be linear, and then the second equation is going to be quadratic. So which means that we're going to get 2 sets of values, 2x values as well as 2y values. And then lastly, under algebra, we discussed the nature of roots. Okay, and under the nature of roots, our main interest is the discriminant or the determinant or the contents of the quadratic formula. So we know that in a quadratic formula, it's b squared minus 4ac over 2a. So our interest is whatever is inside the square root. That is what we are interested in, and that's what we call the discriminant. So if this discriminant that we normally use this symbol of a triangle, or we call it delta, is equal to 0, then we know that the roots are equal. I'll start with that. If the discriminant is greater than 0, then the roots are real. If the discriminant is less than 0, then the roots are unreal, or sometimes we call them imaginary. Okay. Then if the root is equal, if the root is equal to a perfect square, then we can say that the roots are basically rational. Now someone will say, what are roots? What are roots? Basically, if you look at a parabola, the points where the parabola cuts the x-axis, these are what we are calling the roots. So in other words, we shall be discussing the nature of these things. Okay, are they equal? Are they what? And so on. So for as long as the parabola is not reflecting that, then the roots will be imaginary. That does not mean that the parabola does not exist. The parabola exists, but it does not cut the x-axis or the horizontal axis. So that is question number 1. And then when you look at question number 2, not really question number 2, but Topic number 2 that we're going to be looking at is the functions and the graphs. So I think I can start with the contents of algebra before I break down the functions. I think that would make much more sense so that people don't forget. All right, let's go to the sample questions and see what exactly is happening before we introduce the functions, because the functions, there is quite a lot that we need to really discuss. Okay, so here we have our question number 1, which will always be the same question 1 in grade 11 and up. So they want us to solve for x. So first question is a quadratic, which is x squared minus 6x is equal to 7. So step number 1, as a candidate, as a learner, you are required to create a standard form of this equation. Standard form is where everything is left on one side and we have just a 0 on the other. So I'll start by saying it's x squared minus 6x. When the 7 goes that side, it will be minus is equal to 0. And then I have options either to use my factors by opening brackets, or I can use the quadratic formula straight away. Here, the choice is yours. So if I have x there and x there, I can have 7 and a 1. It should be a minus and a plus, so that I get this everything. So product and the sum. So looking at these brackets, x is going to be a 7, or x is going to be a -1. So those are the two answers that we need. Now 1.1.2, where they give us 3x squared minus 2x is equal to 14. For as long as the question gives you this condition, which they will always do, that correct 2 decimal places, please straight away run and use the quadratic formula. But you'll have to first of all create the standard form again. So creating the standard form is going to be 3x squared minus 2x minus 14 is equal to 0. Let me just use this side. So it's 1.1.2. So 3x squared minus 2x minus 14 is equal to 0. Perfect. So from the quadratic formula, we know that's negative b plus minus square root of b squared minus 4a. Please start by writing down this formula, okay, before you do the substitution, because I've seen learners that just straight away use their calculators and only write the answers. You're going to lose marks for that. So from here, we can see that our a is a 3, our b is a -2, and then our c is a -14. Let's do the substitution. So it's a negative with a -2 plus minus the square root of -2 squared minus 4. The a is a 3 and the c is -14. We're dividing this by 2 times a 3. As you're substituting this in the calculator, use one sign at a time for the case where you have to change the positive as well as the negative. Okay. So for as long as you've showed us the substitution, now you can proceed and do your calculator, okay, and get your answers straight away. For those that wish to simplify further, there's still no problem with that, because that will be a 4. This is going to be a 12 times 14, and then we plus together. Everything must be over 6. Let's see, so 12 times 14. That's going to be 168. And then you just punch that into the calculator and we see what we get. So my first answer of x, if I use a positive, remember we also mark the rounding off. Someone is refusing. Oh, I did not add the 4. Thank you. Okay, so that is going to be 172. And then I do my calculator. So x1, or the first value of x, is going to be 2,52. All right, calculator, where are you? So it's 2 plus root of 172 over 6. Come on. So that is x1, and then this is also going to be the second x. So it's 2,52. And then if I use the subtraction between, I'm ending up with negative 1,85. So something like that. Now in cases where you just have one number after the comma, please add a 0 there to make it two numbers after the comma. 1.1.3. So whenever you have a SAD, because this is now a SAD equation with a SAD, step number one, we need to isolate. Okay, isolate the root sign. In other words, leave it on one side of the equal signs. So we have root x minus 2. Okay, we are adding x. This is equal to 2. So when I isolate that, it's going to be x minus 2. I have to move the x that side. I'll be left with x2 minus x. Then I go to step number 2, where I square both sides. Okay, so if I square that, the reason for that is so that we can kill the root sign. So that's going to give us x minus 2 is equal to 2 minus x squared. We can expand this. So use your FOIL, 2 minus x into 2 minus x. Then we open up. So that's going to be 4. I multiply there. Then that side is going to be 2x. I multiply this, going to be another 2x. I multiply that. I have plus x squared. And then number 3, I need to create the standard form. Okay, where everything is on one side and then all the other aspects are left on the other. If not, I can just create a standard form whereby there is a 0 just on the other side. So I'll keep the x squared this side. This is going to be negative 4. When I bring this, it's going to be negative 5x. Then when I move this 2 to that side, it's going to be a plus 6. I can put the 0 here, no problem. But it's the same thing as me putting it that side. Okay, so I have x squared minus 5x plus 6 is equal to, so it's another quadratic. Then I can either solve this quadratic, which is now our step number 4. Solve the quadratic using the quadratic formula or the factors. So I can use x minus 2, x minus 3. Give me that. So in this case, x is a 2 or x is a 3. Then I'll go to the last step where I have to test the answers. Okay, so when you're testing the answers, you have to use the first equation, this equation here. So if I replace x with a 2, am I going to get what is on the right hand side? If I replace x with a 3, is it going to give me what is on the right hand side? So let's see. 2 minus 2 is going to be a 0. Square root of 0 will be a 0. Now plus the x, which is a 2. That gives me a 2, which means this value is acceptable. Let's try a 3. 3 minus 1 is going to be 1. Square root of 1 is 1. Plus a 3. This gives me a 4. That is the left-hand side. But on the right-hand side, I must end up with a 2. So this value is not acceptable. So you can cross this out and tell us not applicable or it's not a solution. So that is the last step. Now, if you miss that last step, you're going to miss out the last mark for as long as all the other aspects correct. All right, then we move on to 1.1.4. So this is an inequality. With the inequalities, there are rules. So, okay, in as much as it's also an equation, but there are things that we need to also understand. This is x squared plus 7x is less than 0. Okay, so let's say, okay, in this case, our a is greater than 0. And the inequality that we are having is less than 0. What matters is how we represent the solutions of this. Okay, so for as long as a is greater than 0, and this is the inequality, which means our answers are going to be the smaller value is less x and less the bigger value. Okay, if it's a parabola, which means we have our roots, the points of interest will be this. Okay, so that will be the point of interest between those two numbers. that lies the solution to the question. If the a is greater than 0, and then the symbol is the inequality symbol is greater, then which means it's going to be x is smaller or x is less than the smaller value, or x is greater than the bigger value. We get represent it on the parabola. Point of interest is this. We'll do the shading. And the point of interest will be that. That will be the shading. So let's answer the question. So you can factorize, use any methods, vectors, quadratic formula, and so on and so forth. So I can see x is common. Take it out. I'll have x squared. Not x squared, it's just x. Sorry about that. So it's just x plus a 7 is less than 0. Which means that my critical values are 0. And the other critical value is -7 if I am to solve this. Okay, but since we said we're having smaller value, less x, less bigger, so it's going to be the smaller value between 0 and -7 is -7. So it's -7 is less x, less 0. So that will be how the solutions will be represented. I prefer this option because I find it a little bit quicker, even for learners. Another option of representing this is just by drawing a number line. Okay, this is here -7, and then that is 0. And then you can just draw a line in between. Something like that. Or you can draw a parabola. Draw your parabola and then indicate that line. And tell us this is a -7. This is a 0, and then you can do the shading of the bottom part. So those are the three formats of how you represent the solutions. I always choose that. You can choose whichever one makes really sense to you. All right, that is question number 1.1.4. Let's look at 1.1.5, which will be the exponents. So under the exponents, we are advised to at least remember all the laws of exponents, because I'll say x plus 3, because it's not that much that they will ask you about exponents, but just a few questions, probably 1 or 2, but those will require at least an aspect. So now if you're clueless of what's going on, it's going to be an issue. So for this question, for as long as you have an equation that has exponents, okay, and there's a plus sign between the terms, there is a minus sign between the terms, you're going to do the factorization. Okay, so let me just try to split this up using law number 1. From law number 1, we know that 3 to the x plus 3 is the same as 3 to the x and 3 to the 3. Bases are the same, you add up exponents. Same story here, 3 to the x and 3 to the 2 must give us 4, 8, 6. Okay. Then I can see 3 to the x is common, I'll take it out. 3 to the 3 is a 27, 3 squared is a 9. This gives us 4, 8, 6. 3 to the x into what is 27 minus 9, I'm getting 18 is equal to 4, 8, 6. Then divide both sides by 18 over 18. So which means 3 to the x is equal to 27. Now we have to just create 27, or we have to rewrite 27 with a base of 3. So 3 to the x is equal to 3 to the 3. So for as long as the bases are the same, which means even the exponents have to be the same. So x is equal to that exponent, which is a 3. All right, so that is that. Remember the laws of the exponents, law 1, law 2, and all those ones, because this could be asked using any other law. Okay, then 1.2, which is the simultaneous equation. I'll say that. They're telling us if we have x squared plus 2xy minus 8y squared is equal to 0, can we determine the value of values of x over y? Okay. So we can see that this is a quadratic. Yes, it's a quadratic. let me write this side where I have enough space. We're saying it's 1.2 x squared plus 2xy. Is it plus 8y squared or minus? It's minus. Okay, so what I'm going to do, I'm just going to try and factorize this out. Okay, I can have my two brackets, x and x. My product is negative 8, my sum is a 4. So I can put a 4y here. No, the sum is a 2. I can have a 2y here. If I make this a positive and make this a negative, if I open this up, I'll have this entire expression the way it is. So from the first point, I know that x plus 4y must be a 0. And then x is going to be equal to negative 4y. But we need the ratio, so divide both sides by y. So x over y is a negative 4. Or alternatively, x is going to be equal to 2y. X minus 2y is a 0. Then x over 2, no, it's x over y. That's what they want. It's going to be a positive 2. So these are the ratios that the question is demanding for or asking for. All right, so negative 4 and a 2. Then question 1.2.2. Hence, there is no otherwise. They want us to determine the value of x and y if x plus y is a 6. Now they are telling us that if our x plus y gives us a 6, we must find x and y. So we could use any, or we're going to use both. I'll say that. So from this equation, let's make x the subject. So let's make whichever. So I'll make y the subject, which is going to be 6 minus x. I'll call this equation star. And then I'm going to get this equation, replace it there, and replace it there, and then look for my x values. So that's going to be x over 6 minus x gives us a negative 4. You can cross multiply. X is going to be negative 24 plus 4x. Is that okay? Yes. I'll move the 4x to that side, which is going to be a subtraction. So negative 3x is negative 24. Divide both sides by negative 3. X becomes 8. Then I'll do the same. So if x is 8, let me just substitute it there. So that y is 6 minus 8, which is negative 2. Then let me do it on this other side. I'm going to say x over 6 minus x gives us a 2. Cross multiply, x is going to be 12 minus 2x. When I transpose the 2x, that's going to be 3x is 12, which means x is a 4. Substitute this into that, y is going to be 6 minus 4, which is a 4. So we need this x and that y, and then we also need this x and that y. So that is how the simultaneous question would be asked or would be answered. Then question number 2. We still have more simultaneous down there. Question number 2. If 3 is one root of this equation, they want us to determine the value of k. So one thing we know about roots is that for as long as we get this number and then replace it with x, the answer that we get must always be a 0, since we're talking about the x-axis, and then the y is always 0 for the x-axis. So if I get 2 into 3 squared minus 3 into 3 is equal to negative k. I can move this k here so that it's a plus k, and then it should be equated to a 0. Okay, So if I substitute, have 3 squares is 9, that's going to be 18 minus 9 plus k must give us a 0. Why am I saying 19? I said 9. Okay. So which means that is a 9 plus k is 0. So k is a negative 9. That's what I'm getting. And then they want us to calculate the value of the other root. For me to do this, replace k with a negative 9, then move it that side. Okay, and have 2x squared minus 3x minus 9 is a 0. Okay, and then they want us to factorize that or simplify that. So already we were told that x is a 3, so we're going to have x minus 3 here. And then how do we get this 2x? Can put a 2x here. How do we get this? That's going to be a 3 plus. That's 3 minus 6, that's negative 3. Okay, perfect. Then this other root is going to come from this bracket, which means x is going to be negative 3 over 2. Okay, so that is 2.1.2. And then 2.2, where we need to solve the simultaneous again. The question is telling us 2 is equal to x minus 2y. And then the other one is 2 is equal to x squared minus 2xy plus 3y squared minus 2. Okay, so if I look at the two equations, remember what we said. Look for the linear equation, which is this. Make one variable the subject. So I can make x subject. So I have to move everything that side. So x is going to be 2 plus 2y. I'll call this my equation star. Start by calling this equation 1, call that equation number 2. And then we substitute equation star or equations 2 into equation number 2. Then this is going to be 2 is equal to 2 plus 2y squared minus 2y into the x, which is 2 plus 2y plus a 3y squared minus 2. The aim of doing the substitution is so that we have just one variable at a time. So 2 is equal to, when I open this, please the FOIL, that's going to be 4 plus 8y plus 4y squared. Open this up, minus 4y, and then minus 4y squared plus 3y squared minus 2. Let me collect the like terms. I have minus 4 plus 4. This can cancel that. Then I just have 3y squared. Okay. 8 minus that, that's plus 4y. We know that 4 minus 2 is going to give us a 2. But that 2 will cancel with this 2. So I'll be left with no constant. Just that. Then I take out what is common. I'll be left with 3y plus 4 is 0. So either y is a 0 or y is a negative 4 over 3. So y is a 0, 4, 3y plus 4 is a 0, and then we solve for y. Then if that is correct, I just need to get these numbers for these values and substitute them into equation star, which is 2 plus 2y. Okay, we said x is 2 plus 2y. So if y is a 0, x is going to be 2 plus 2 times 0, which gives us a 2, or x is going to be 2 plus 2 multiplied by negative 4 over 3. And then that must give me 2 plus negative 8 over 3, which is negative 2 over 3, if I simplify it further. All right, so that is question 2.2. 2.3, we still have exponents here. They are telling us the fourth root of all of this. What we do? Leave your answer with positive exponents only. So I think I can do it here. So step number 1, we know that the fourth root is the same as exponent 1 over 4. So I'll break down what is inside 3 to the x. The 9 is the same as 3 squared, but we have x plus 1 as an exponent. Then over 27 is 3 cubed. Everything is x plus 2. And then the whole of this is to the exponent of a quarter. Okay? Since the bases are the same up here, I can do the addition. So that's going to be 3 into 3x plus 2. Remember, I'm adding this because 2 and x is 2x plus that is 3x. 2 times 1 is a 2. I'm dividing it by 3x plus 6. Okay, it's your choice to either do the splitting or the subtraction. It's your choice. If I split, it's 3 to the x, 3 squared. 3 to the 3x and 3 to the 6. So this cancels that. I can see that the bigger exponent is down. So I'll subtract from down. I know that 6 minus 2 is a 4. So I'll be left with 1 over 3 to the 4. You can leave it like that. Or you know that 3 to the 4 is the same as 81. Or you can give it as 1 over 81. Okay, that is 2.3. 2.4. 2.4. They want us to determine the value or values of m for which this has 2 magnitudes but of opposite signs. 2 magnitudes but of opposite signs. So step number 1, I'll have to rearrange this. 2x squared plus mx minus 5x minus 8 is a 0. I can group this together since they have something in common. So 2x squared plus, I'll have m minus 5 into x minus 8 is equal to 0. So for me to have opposite signs, okay, then this b part must be a 0. In other words, if the b cancels out, then I'm happy. If the b is a 0, then I'll be happy to have opposite signs of the graph. So I'm going to say m minus 5 should be a 0. So m has to be a 5. So if that is a 5, that will cancel, and then my graph will be on either sides of the y-axis. All right, I'm going to skip question 3 because number patterns is for term number 4. Okay, but at grade 11, we are able to do question 3.1 only. The quadratics, we shall find them in term number 4. Then I'll go back to the functions. So the other aspect or the other part of the paper, we'll have to include functions, or these functions are normally called graphs. Now, we have different types of graphs, okay? And we have those ones that specifically come in paper 1, and we have those ones that come in paper 2. So with paper 1, we should expect, number 1, things to do with a straight line, okay? The general equation of a straight line is mx plus c, whereby m represents the gradient of the line, and then c represents the y-intercept. We can have this format, or we can have y minus y1 is equal to m into x minus x1. You guys saw these formulas even when you were dealing with analytical geometry. Okay, so it's the same aspect. Now, we know that for as long as lines are parallel, okay, line 1 and then line 2. So for parallel lines, M1 must be the same as M2. And then for perpendicular lines, This is line 1 and line 2. This is perpendicular. We know that M1 times M2 must give us a -1. That is to do with a straight line. You need to know at least how to determine the y-intercept. You need to know how to determine the m, which m is the gradient. Remember, it's change in y over change in x. So if we have y2 minus y1 over x2 minus x1, then we move on to the next graph. Or before we move on, if they ask for the domain of a straight line never ends. X is an element of real numbers. If we ask for the range, these are the y values. Y will also be an element of real numbers. Let's look at the next graph, which will be the parabola. So this is also known as the quadratic function. Okay, so this one is so unique because it has 3 different ways of being expressed. The first one is ax squared plus bx plus c. Okay, so if we have this and we want, let's say, the axis of symmetry, because the axis of symmetry is just the x point where we find the turning point, or the x coordinate of the turning point. So it's -b over 2a. Now for us to get the y point of the turning point, or the y coordinate of the turning point, just get this value and substitute it into the original. If we ask about the shape of this parabola, it's usually a smiling face, or a smile, concave upwards, and then it's concave downwards, something like that. So this happens if the a is greater than 0, if a is less than 0. Those are the scenarios we have. So this is axis of symmetry. If we ask for the domain, x values, x will be an element of real numbers. So let's say this graph is turning at a point y2. This graph is turning at a point y2. And then we need to determine our range. Remember, range are the y values. Okay, so for as long as the graph is a frown, and then the range is going to be y is less or equal to y2. If the graph is a smile, then the range is going to be y is greater or equal to y2. Please pay attention to those inequality symbols. Then the second format of a parabola is y is equal to a into x minus x1 into x minus x2. In other words, we have these points. So this is known as the intercept method, or the root method, whereby x1 and x2, these are basically the roots, the points where the graph is starting, the x-axis. So what happens is that the a is still indicating the nature of the graph, whether it's a smile or a frown. Now, if we need the axis of symmetry from this format, the x will be just the midpoint of those things. So if I were to draw a parabola, this first point here will represent my x1. This will represent my x2. So for me to get the axis of symmetry, that line that divides the parabola into 2, I'll get x1 plus x2 divided by 2. And then the y coordinate, I'll do the same thing, and then the turning point, and so on and so forth. Same story with the domain and the range as the first aspect. Okay? And then the last format for the parabola is y is equal to a into x. You can say plus p squared, and then plus q. These signs can always change to plus or minus. So this is known as the turning point format. Okay, this, they will give you the turning points already from the graph themselves. So if we ask for the axis of symmetry, you know, say x must be a p, the value here. If it's a positive p, then this becomes a negative p. If this was a negative, then this becomes a plus. And then the y value is going to be q. So in other words, if we ask for the turning point of the graph, it will be a P in the Q. Let me call it a negative P since I use the positive way. So that sign will always change whenever we have this turning point approach. Domain is still going to be the same, and then the range in this case will be just direct. Y is greater or equal to Q, since the Q is positive, and then this is also a smiling graph. So these are the three aspects of the parabola that we need to know, that we need to familiarize ourselves with. Okay, just know at least how to sketch. I think I'll touch the sketching part at the end. Let me move on to the next graph, which is the hyperbola. The hyperbola is always given with the denominator having a variable. So in other words, we have 1 over x plus p plus q. You can say y is equal to that. Okay, whereby p and q, okay, these are what we call asymptotes. So when you ask for the vertical asymptote, okay, a line that the graph can never cut, it will be equal to that. X is equal to, I'll say negative p since I'm using a plus. If this was a minus, then that would be a plus. And then the horizontal asymptote, we're going to say y is equal to q. If q is positive, then it will be positive. If it's negative, it's also negative. The signs are not changed. Now, let me just put that as an A. We know that the shape of a hyperbola is that we must have two arms. In grade 10, it was very direct. Let me take this to be our A is greater than 0. So the hyperbola must be in quadrant 1 and then quadrant number 3. If the A is negative, then this hyperbola must be, let me still use the same asymptotes, must be in quadrant number 2 and then quadrant number 4. Okay, so if A is a negative, then it should be in this format. If A is positive, it should be this one. So this is the only graph where we have two graphs or two arms that are plotted. Pay attention to that. Now, other thing that they love about this is the axis of symmetry. Axis of symmetry is just the line that divides the graph into two. With a hyperbola, we have two of them. We can have one with a positive gradient and then the other with a negative gradient. So the general equation, since the straight line, is going to be x plus c, or y is equal to negative x plus c. So these are the general forms. Now, question will be specific on which one we want. That's how we determine that. And then the last aspect of the graph, we have what we call exponential graph or exponential function. So this will be given in the form of y is equal to, I'll say b to the x plus q. Now, if b is greater than 1, then the graph will be increasing in that format. But if our b is between 0 and 1, otherwise a fraction, then the graph is going to simply decrease. Now, q represents what we call the asymptote, the horizontal asymptote. So pay attention to the q, to the p values. Now, I'm going to erase all of this and take you back to what we said. That for as long as, okay, for as long as you're being told to sketch a graph, most important part will be the intercepts of any graph. So for us to get the x-intercept, we always let y to be a 0. And then for us to get the y-intercept, we always let x to be a 0. Now, in grade 11 and upwards, instead of us saying y is equal to this y is equal to that. These are going to be changed into the normal function notations, whereby we talk of f of x is given as b to the x plus maybe a q, g of x, h of x, k of x, and so on and so forth. We just need to pay attention to that, because f of x simply means y. Okay, so having given people the background of functions, we need to look at our sample questions. So remember, in paper 1, we don't expect the trig functions. It's just the straight line, the parabolas, hyperbolas, as well as the exponential in grade 11. All right. So I'm going to look at the first one, which is going to be, okay, so question number 4, we're being told that f of x is negative 6 over x minus 3 minus 1. So the question is, what type of graph is this? Now, for as long as the denominator there is x there, automatically this is a hyperbola. Okay, they want the coordinates of the y-intercept. So for y-intercept, we said x must be 0. So that's going to be negative 6 over negative 3 minus 1. That's going to be a 2 minus 1, that's a 1. So it's going to be 0 and 1. Then they want the coordinates of the x-intercept. So x-intercept, y is a 0. So we said f of x is the same as y. Okay? So replace f of x with a 0, and then we solve that. So it's going to be 0 is equal to negative 6 over x minus 3 minus 1. And I have to move this first. So that's going to be 1 equal to negative 6 over x minus 3. Cross multiply, that's going to be x minus 3 is equal to negative 6. Move that side, which means x is a negative 3. So the coordinates are going to be negative 3 and the 0. Then next, they want the equations of the asymptotes. So there is this negative 1. Tell us why is a negative 1. For we need the x1, not the whole, and this one, change the sign. X is a positive 3. And then 4.4, they want us to sketch that. So there is a page that's been provided. So 0, 1, negative 3, and 0. Let me just sketch it and see. So if I call this a 1, 2, 3, 4, and 5. Negative 1, negative 2. That isn't that too much. Let me just call this a 1. Call this a 2. Call this point a 3. Call that a 4. So that our graph is at least healthy. Negative 2. This is going to be negative 3. Okay, and then up here, and call it a positive 1, positive 2, positive 3, positive 4, negative 1. Let me have this as a negative 2, negative 3, negative 4. So I'm doing this just because they gave me a grid, but in normal cases, I don't need to use a number line. Remember, it will be a sketch. So I have my asymptotes as 3 and negative 1. X is 3. It's going to be this line here. When y is negative 1, it's going to be this line there. Okay. And then our A is positive or negative. It's a negative. So it means we expect the graph to be in quadrant number 2 and then in quadrant number 4. So for that to happen, okay, so then the intercepts, we say 0 and 1. Where is 0 and 1? 0 and 1 is somewhere here, okay. And then the other intercept that we saw was negative 3 and 0. Negative 3 and 0, which is this point. So which means our graph must be moving in this. Let me just have this. Must pass there and then continue in that sort of direction. Remember, it should be just a smooth graph. Must be a smooth graph that is not cutting the asymptotes. It must not cut the asymptotes. So the main point, we want to see the asymptotes there. We want to see the intercepts. Now for this part, where we don't have any points, you just have to draw an extension so that our graph is going to be in this format. So these are the two arms of that parabola, of that hyperbola of ours. Then they want us to determine the value or values of x for which f of x is greater than 0. So where do we find the graph to be above the y-axis? So we can see that from this point where x is negative 3, the graph starts to go above the y-axis. Okay, but now after this asymptote, the graph is below again. So which means this has to be the end point. So we're going to say negative 3 is less x. Okay, let me just do this. Okay, so we're saying negative 3 is less x, and then is less a positive 3. So this interval, the graph has to be above the y-axis. That's greater than 0. Okay, then they want the average gradient of f between x negative 2 and then 0. So in this case, if x is negative 2, if x is 0, let's get the y coordinates here. Remember, y is negative 6 over x minus 3 minus 1. Put a negative 2 here, it's a negative 6 over negative 5 minus 1. What is this going to give us? That's positive 5. So negative 1 over negative 5, which is a positive 1 over 5. Then I do the same with 0. Remember, with 0, we got to 1. Okay. So our coordinates are going to be 0 and 1. And then we're going to have negative 2 and then 1 over 5 for 0,2. Use the same gradient, y2 minus y1 over x2 minus x1. So it's going to be 1 over 5 minus 1 over minus 2 minus 0. Okay, simplifying that, that's 1 minus that. It's going to be negative 4 over 5 divided by negative 2. Okay, so if I try to simplify this, what do we end up with? What do we end up with? I end up with 2 over 5. So negative 4 over 5, multiplying by that. So it's 2 over 5 positive. Okay, that is the gradient. Then 4.7, one of the axes of symmetry is increasing. Okay, so it's increasing, which means the gradient is positive. Then let's use the equation with the positive gradient, which is x plus c. For us to get c, we need to use the coordinates of the asymptotes where they are meeting. Okay, so we said x is a 3 and y is a negative 1. So negative 1 is equal to 3 plus c. Our c is going to be negative 4 when you move the 3 that side. So the equation becomes x minus 4. X minus 4. So this becomes the equation of the axis of symmetry. All right, then question number 5, we have a parabola and a straight line. Sketch below. The graph G passes through point E and all of that. Those are the intercepts. The line of symmetry is that. I mean the coordinates of the turning point. Okay, so for us to get the turning point, you need to get the axis of symmetry first. 5.1, x is going to be negative b over 2a. Our b is negative 2, so negative and negative 2 over 2 times negative 1. Okay, so that's going to be a 2 over negative 2, which is a negative 1. Then I have to substitute this negative 1 back here. So negative into negative 1 squared minus 2 into negative 1 plus 3. So that's get negative 1 plus 2 plus 3, which becomes a 4. So which means my turning point, which is C, is going to be -1 and a 4. All right. Then 5.2, they want the length of AB. So they are indirectly asking us to solve. Okay, so when you look at A and B, the graph that is passing through A and B is the parabola. So I have to use that equation. So I'll get -x squared minus 2x plus 3 is equal to 0. Divide through by the negative is x squared plus 2x minus 3 is a 0. I'll factor this out. It will be x and 3, x and 1. This is a plus, this is a minus. So which means x is a -3 or x is a 1. Now, A is going to be -3 and 0. B is going to be 1 and 0. Then they want the equation of G. Now, since I have this as a -3 and 0, I have this as -1 and 4. I can start by getting the gradient and then find the y-intercept. Remember, G is a straight line and it must be in the form of mx plus c. So my gradient is going to be 4 minus 0 or -1 minus -3, which is 4 over 2, which is a 2. Okay? Then I can say, I can use this point and say y minus 0 is equal to 2 into x minus -3. Remember that equation of y minus y1 is equal to m into x minus x1. This is the equation that I'm using. So make y the subject. It's going to be 2x plus 6. So this becomes my equation of interest. Then 5.4, calculate the maximum length CE. Where is CE? Somewhere there. Calculate the maximum length of line CE. Okay, so we can see that CE is basically the distance between, okay, that's the distance between this point C and this point E. We know that Y is 4 at that point, and we know that E is a 6. How many marks is this question? It's 2 marks. So there's nothing much to stress about with this question. So what we're going to do is we can just subtract this 6 minus 2. Okay, sorry, 6 minus 4, which gives us 2 units. So if that is 2 units, then that becomes our maximum length. Then 5.5 times the values of x for which f of x is equal to g of x. So where do we find f of x being the same as g of x? So at a point A, where x is a -3, and then also at a point C, where x is a -1. So those are the points where the two graphs are equal to each other. Okay, so that is what we do in that case. Then we move on to the next part, where f of x and g of x will be less than 0. So what this means is that if we look at the graph of g is increasing, it's above, the graph of g is decreasing, it's below. Or this is negative and then that is positive. When I look at point A, this graph is below and this graph is below. If we move at A to that direction, which doesn't make sense. Between point A and point B, you can see that both graphs are above, which means both graphs positive within those regions. Okay, which still will not make sense for me. So what I need to do in that case, since I have this saying what I need to do in that case is look at this point B. Okay, because at point B, one graph is below and then the other graph is above. So that is the point of interest. So between B to the positive infinity. Okay, so all I'm going to say is either x must be greater than 1. I think that's the perfect one. Or you can say 1 is less, x is less positive infinity. Either way. So that would be one option to represent that. Then question number 6, they're telling us to sketch a neat graph of x squared plus bx plus c. So this is a parabola that we just need to sketch. So number 1, a is less than 0, which means this is a frown. Okay, and then b is less than 0, which means the graph is on the left of the x-axis, sort of the y-axis. And then if c is less than 0, c is the y-intercept of the graph. And then if the discriminant is equal to 0, which means we have equal roots. Okay, the roots are equal, which means the graph is just touching one point of the x-axis. So this is going to be something like this. That's your y, this is your x. Then we can have something like this. You can just extend it just like that. So for as long as you draw a nice parabola in that format, and that will be the answer. Question number 6, which is the last one, telling us sketch below is f of x, which is a to the x. So this is an exponential. Okay. Point R with y-intercept of f, t is 29. Okay, perfect. They want us to get the value of a. So just do the substitution. We said f of x is the same as y. Y is equal to a to the x. 9 is equal to a squared. Can we break down the 9 with something squared? So 3 squared is equal to a squared, which means a is a 3. Or you can find the square roots. Okay, but this is an increasing, so a becomes a 3. Then write down the equation of the asymptote of f. So since there is no addition, so which means y is going to be equal to a 0. That becomes the asymptote of the graph. Then they want us to write the range. Range will be the y values for which the graph is valid. So we're just going to say y is greater than 0. So above the x-axis, the graph we can see is valid. Then they want the coordinates of r, which is the y-intercept. So we know that at the y-intercept, okay, x will always be a 0. So our graph is y is equal to 3 to the x. So replace x with a 0, it's going to be 3 to the 0. Anything to the exponent of 0 will always be 1. So that is 0, 1. Then 6.5, the graph G is obtained by reflecting f about the y-axis. Okay, now they want the equation of the new equation. So which means if we have another equation in this format, whenever you reflect about the y-axis, the value of the x or the sign of the x must change. So which means the graph is going to be 3 to the negative of x. Or somebody can alternatively write as y is equal to 1 over 3 to the x. Then lastly, if h of x is 3 times f of x, they want us to write down the asymptote of h. So 3 multiplied by 3 to the x, there's not much of a difference that's going to happen, because by multiplying by 3, you're basically making the graph bigger, but the asymptote will still be the same. So we're still going to say y is equal to 0. So guys, that is that with your paper 1. I think I'll stop there. Let's meet in paper 2. All the best. Thank you very much.